who watch it always watch the recordings, never join. So
Really?
It's a value because the time is hard for some people at least. To talk to.
Yep. So we are recording, and tonight it's an open meeting. It sounds like we have a couple of presentations, one from Joe Speed on the AI computer, and then an update from Bob. But we can go around the room, no particular order, but Joe, if you'd like to start us off.
Yeah.
Pole position.
Sure, happy to. So let me just let me pop open a link or two here. And okay, fair enough. Well, let me go ahead and share. Share screen, desktop, share. Cool. All right, you guys see my screen okay?
Yep.
All right, so anyway, so I'm Joe Speed. Some of you guys met me before. So I work for ADLINK. I'm on the ROS TSC, the OpenADX TC, the what's the other one? AutoWare Technical Steering Committee, and on the board of OMG, which is the parent of DDS. DDS is the middleware for ROS. So we're super into DDS. We're super into ROS, and we make a lot of bits for robots, right? ABB, Denso Brain, whatever. And even things like autonomous tractors and such things. Well, we're in like a week or so, something like that. We're launching a industrial AI vision developer kit, and our folks, they had this idea for this is what it would be, and this is the chips and the content and what have you, and they came up with, well, this is how much it's going to cost to manufacture, and my CEO's like, don't care, it's going to be $199. And so for this first batch, you actually can get them for below manufacturing cost. I don't know if y'all ever heard of a SMARC module, but what you have is, this is a carrier, and underneath it is a SMARC module. It's smaller than a credit card, and it's got an Intel Atom and a Movidius Myriad-X, 4 gig of RAM, and some other bits. The carrier itself, it's got GigE, USB 3, a lot of things you expect. This is an interesting bit. This is the 40-pin Raspberry Pi HAT connector. So you can do x86, so you can do an x86 board, but use your Raspberry Pi accessories. So it's pin compatible with the Raspberry Pi. So we thought that was kind of interesting. So this is, so when you get it, it's got some software for doing computer vision stuff, but this is the same thing that Rover was running at ROScon in Macau on their rovers. And so they're running ROS2 with cameras, LiDARs, whatever, all things they're doing. And there's like a whole community that folks are putting together around computer vision things that you do with it. There's some demo videos that, are these any good? I don't know. No, that looks like terrible marketing. Somewhere there's actual good videos, but it isn't there. And then I thought this bit was interesting. So basically, if you have an idea for something cool you want to do with it and you'll write or blog about it, you can just click here to apply, and they might send you a free one. So I think we all like free.
Free,
like free is the only thing better than buying it below manufacturing cost, right? Yeah.
Yep.
So and that's it. And I'll put some links. I'll put some links in the in the whatchamacallit, the Slack.
So what is Go250?
Go to 50. It's some reference to like go to 30, but it's a which is some reference to basic. It's basically like the guy who runs this product and this project in this community. He's sentimental about basic. So it's a reference to that. And he's like, this is what I want to name it. And people are like, sure, do what you want. Yeah, so that's Paul Wheels on our team out in Newcastle, UK. Oh, so, I mean, here's just that's just a GIF, but I don't know if you can tell, but it's doing classification on the people running around. There's some other ones in here somewhere where, you know, classification on workers, you know, that's a hat, that's a person. This is counting boxes of cookies and boxes as they go by to make sure you don't ship the wrong ones. So, yeah. So, anyway.
So Go250 is a, sorry, Go250 is a community that is like operates the distribution of this board.
It's supposed to be a community of like brainstorming. They're pretty focused on computer vision stuff, and
Sure.
but if you think about, you know, I think for ROSAG, there's a lot of interesting use case. If you think of it as like, you know, camera on wheels, mobile vision, visual inspection kinds of things. You know, don't run over the turnips. All of these kinds of things. I think the vision is, you know, obviously useful, because on like the higher end commercial side, you know, we got people using our gear to do things like, you know, as the, and apologies for not knowing all the farming terms, as the as the big piece of farming equipment is going along and spraying just the weeds, not the crops, using cameras, right? So that
Great.
kind of stuff.
Sure.
And so I'll go ahead and just paste into the Slack, give you a couple links if you want to poke around at that.
And when is that shipping?
So we shipped the first batch to Arrow. So you go to, it's like you go to the AWS and you click, you go to the AWS and you click like shop here, and it takes you to Arrow to do the fulfillment. They don't have them. Arrow will quote or take an order, but they're not doing the like click to order yet. I think that's a week or two away, but Arrow's already physically received them.
Okay, excellent.
So Arrow Electronics, I don't know if you guys probably know who that is.
Yep.
Yeah. And then giving our link here.
And that's running the Movidius and OpenVINO.
Yeah, so they ship with Debian, I think Debian Stretch, and it's got the OpenVINO, the drivers for the RHAT 40-pin connector and all that. Rover Robotics and others have thrown Ubuntu, what's 18, Bionic, onto it without issue. And yeah, so typically it's for doing the OpenVINO, and then something that's included with it is software that, if you want, and you can run the OpenCV, you can do everything local, but one of the things it also includes is you can connect it to an AWS account, and it'll take photos from whatever camera's connected to it, send those up to a S3 bucket. You bring those into SageMaker, which is the ML model development tool on AWS, and that will generate the model, and then that gets pumped through an OpenVINO quantizer, optimizer, and then that optimized runtime gets published back down to the device. So, you know, the idea is to be able to develop ML models, you know, install it on a thing or in a place, capture data, develop models, deploy and manage the models without writing a bunch of code.
Wow. That's really interesting. So you can deploy that model from the Amazon cloud down onto your device?
Yes.
It goes both
Yes.
directions.
Yeah, it actually runs AWS IoT Greengrass, or can run Greengrass. And we work with the AWS and Intel people to like put together that entire closed loop. Actually, here I've got a AWS. Here, I'll show you what that looks like.
That would sure make things a lot easier. You know, like sometimes we'll train a model locally and then you have to change the format to get it into some model that the Movidius can run or OpenVINO.
Yeah, and that can be a real pain.
Yep. Yep.
Not to put too blunt a point on it, but here, so you can kind of get an idea here. So what you have is so basically from here down is all running on this Vizi-AI. So you connect your camera, there's a piece of software that's reading from that. It publishes the data to AWS Greengrass, which I think because I'm on a black background, you're not seeing all the arrows. But from Greengrass, it pushes it up to an S3 bucket. Those get pulled into SageMaker. You develop your model. The trained model gets pushed to another S3 bucket. S3 buckets are just AWS storage, like Google Drive or something. And then from there, there's an Amazon EC2 compute instance that runs the OpenVINO model optimizer. So it pulls in your, you know, TensorFlow, PyTorch, whatever you did here in SageMaker. It pulls that in, optimizes it, and then that gets published back down and gets run in the device. So we have kind of that whole closed loop working for you.
That's excellent.
So where I want to go with this is I want to take this and integrate it in with ROS2. You know, I think right now today you could run them together, but where I want to get to with this, and I've got some engineers assigned to help me, is to, you know, get this all packaged in, working nicely with ROS2 instead of just alongside ROS2.
Okay. Yep. But it definitely looks like learning that workflow would be helpful, and then it'd be a smooth transition if you wanted to go to ROS2 on that full system.
Well, that's my idea. You know, like I think cameras are interesting. I think robots are interesting, and you know, Rover and some other customers really clued me in that, you know, a really interesting, particularly hot topic is when you smash those two topics together. So the mobile vision, quality inspection, security, ag, all of these kinds of things, when you got, you know, camera and robotics working together.
Mm-hmm.
So you know, I think this is a tool for that, and we're going to have different flavors of this, right? So like I just showed you that one, and then here's an ARM version that is available for purchase right now, and it's find my share button. Share, and I'll put this in the Slack too. Slack. So this is called a RPi, which stands for Industrial Pi, though it's not a Raspberry Pi. So I don't know. It's someone smarter than I will know if that's appropriate naming. But so it's the same carrier, okay? But this one actually has a Rockchip SMARC module, and we make these SMARC modules. So if you all have seen, like, you know, PCIe PEG cards, like big GPU cards, there's a industry specification for PEG cards, PCIe cards. There's industry specification for like COM Express, right? For MXM GPUs, And SMARC is a similar thing. So SMARC is just a industry standard for these small form, typically like up to 15-watt compute modules that you can plug in. So with this one carrier, you can plug in, you know, there's a bunch of people that make these, right? You know, we make them, other people make them. But even just for ourselves, we make 24 different compute modules that snap into this carrier.
So this one, this iPi, is it sort of like interchangeable? So you could just swap out that other board with this one?
Yeah, because the carrier is the same. And this one, so I've never done this before. Let's find out how much they cost. Buy now. They are $125 US. So I think they launched this today. So, yep. So for 125, you can get this. For 199 in a week or two, you can get the one that is x86. It's an Intel X5 E3940, which for any, you know, Intel Atom nerds, you know, it's 4-core, I think 2 gigahertz, and then it's got the Movidius Myriad-X, which, you know, depending on your model, you can figure out what kind of frame rate you get out of that. Like, I don't know, typically something like 15 frames a second, depending on your model.
Okay.
Something like that.
Yeah, that's an amazing small form factor x86 with, that sounds really exciting.
Yeah, they're cool, and there's nothing proprietary about it. You know, like I said, you can get SMARC modules from us or, you know, whoever. But these are some, what we saw is you kind of have these, you know, toys isn't the right word, but we're just trying to help bridge people into, you know, more of the industrial style of gear. So for example, you know, we make these rugged industrial smart cameras that are used in factories and food processing and different kinds of things. So this is like, you know, the same compute, but in a really inexpensive dev kit.
Awesome.
And that's as much spiel as I'm going to do on that. It's I couldn't in good conscience do it, except I know we lose money on them anyway, so I figure it's okay.
Well, it's good to see what's out there and what's coming down the pipe. Appreciate that.
So when this batch is sold out, the next batch, the price goes up some. I don't know how much.
It'll lock in the deal now.
Yeah. Well, like I said, you know, you can click the link I put there in the Slack, and you can say, well, this is what I think I will try to do with it, and I'll make a blog or a tutorial or a demo video, and if you copy me or ping me separately, like I'll put pressure on them, and we'll try to get you free ones.
Cool. Yeah. Well, we are working on just exactly, you said, weed identification and then mechanical weeding or spraying. So that's right in line with a couple of projects.
One of our friends, where was it? There was one that it actually shows that he was using it to do computer vision for, like, where do you pick sweet potato snips? Like, what's the right place to grab it? Here, does video work okay if I share it?
Should.
Okay, let me, last one, and then I'll get off my high horse. Share, desktop, share. And can you all see that?
Yep.
So this is, you know, some of the stuff. So some of this is like robotics parts picking, pick and place. Some warehouse logistics, but somewhere in here there's it was actually oil rig, blah 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 blah. Here we go. So here it's actually figuring out, the computer vision is showing the worker where to grab the produce, except that one's actually for a robotics produce picking application. So, so it's telling the robot arm where to grab it without damaging it.
That's excellent. Sorting strawberry seedlings is a tough task that would be great to automate.
Absolutely. Absolutely. The should I paste these links just into the Slack, or you want them in the Zoom?
Either or. If the Zoom, then we just I kind of copy the chat and then put that into Slack, and then also post that out on YouTube.
Oh, gotcha. All right. So maybe as things go on, I'll just I can I'll paste them into the, so I put them in the Slack and I'll paste them into the Zoom chat like as the meeting goes on.
Okay.
All right.
Sounds great.
Cool.
Thanks, Joe.
Appreciate it. Thanks for humoring me.
We also have Bob Hassett. He's coming out of hibernation. He's already strapped a couple of actuators on his tractor and doing a lot of testing. You want to give us an update on your project, Bob? Are you there?
Yep, I think, can you hear me now?
Yep, I can hear you.
Okay. I've been dormant for about a year with too many other things going on, and just recently started. My whole approach to this is use what I have or what I can find around, laying around the shop, and what I can easily make. And I'm focusing just on the hardware interface to the tractor and just using momentary switches for control. So I had some actuators that I salvaged from a high-end floor sweeper, and everything was rated for 36 volts, but I was hoping to run it on 12. Long story short, I found a step up from 12 to 24 volts, and I can run things on 24 volts. But then Jeff jumped in and said, well, you better figure out how fast you can stop. So there you go. Stuff from Menards or what I've got laying around. And so when I press, if I have the throttle going and I've got the forward reverse, or I'm going in the forward direction, as soon as I hit those switches, it takes about 6 feet for me to stop, for the travel to come to neutral and the throttle to go to 0, which is way too slow. So I'm pulled those out. I've dug around the box again, the junk drawer, and there's 36 volt motors that came, and now I'm working on those. I mounted the 36 volt motor on the steering wheel running at 24 volts, and that's got plenty of snap to it. So hopefully down the road I can moderate it more with the computer. Now this week I'm working on throttle control. I removed the actuator, and now I'm trying to use some woven wire, which is kind of like the stuff you use to hang pictures on the wall. Very thin, very strong. And then I'm using some round pulleys to go around corners, and I'll mount that motor onto the side because there just isn't enough room. The big problem I'm going to be facing is the forward reverse travel pedals. There isn't a whole lot of room, and it has to be quick, as quick as, you just take your foot off and it goes to neutral. So I'm looking for some kind of a way to use the actuator, but then speed up the time through a scissors action or something like that. I don't have a clue yet how I'm going to do it. But the rest of my parts will be coming in on Thursday, and I should be able to show something about the steering and the throttle control with the two DC motors. So that's about it where I'm at right now. I can foresee this. The big problem with this electrical box is there's too much wire in a small space, and it doesn't short out, but it'll open. So if I get too much vibration, things stop working. So I'll have to redo that box somehow. I like what someone used was like a briefcase box, an equipment box, and maybe I'll move all these controls on top of that, a little bit of a toolbox instead.
Oh,
so
it's got to be big enough to climb in.
yeah. Yeah, so it's I'm just starting out, and I'm still learning ROS, and I'm just beginning my journey. So I got a long way to go, but that's about it.
Okay.
So Bob, in the past, I've used Pelican cases, and they're very pricey, but they have everything you need, like waterproofness and ruggedness.
Okay. Yep.
And they're typically used for transporting camera gear, but
Okay.
I think they work really well.
Yeah.
And cheaper ones are available. I just used one.
Yeah. Okay. Jeff gave me an idea about something about using one of those cases in a portable design where possibly I can take it off of the tractor and put it on the bench and develop my stuff and then put it back on the tractor. So the big question then is to find the connectors and stuff like that. I have found an old battery drill case that was easy to gut out, and there's lots of room in that, following that Pelican case idea. So I might go that way. Everything's still up in the air. I'm flying by the seat of my pants. So that's about it.
I recently was working on a project that they put it's a Pelican-like case on the mount for the slow-moving vehicle sign on the back.
Yeah.
And I like Deutsch connectors, so we used a 29-pin, I think, Deutsch connector. So we could just disconnect the Deutsch, pull it out of the SMV mount, and take it to the bench to work on. Very handy.
Like that idea. Yeah, I like that idea.
I'll also throw in I always recommend put a strip of lights, put an LED light in, aquarium lights, they're commonly called.
Yeah.
I love to have a strip of lights in my boxes in the middle of the night when I'm in the middle of a field. It is wonderful to open the box and have it all lit up.
Ah, good. I'll do that one too.
So not just for mood lighting.
Yeah.
It enhances my mood when something is smoking and I can actually see it.
Oh. See rather than smell.
Another thing I've done in the past is, you get rid of all the foam that comes with your Pelican case or knockoff. And at least in the earlier lab I worked in, we would laser cut like a pegboard almost with little notches, so that when you put your electronics in there, you just strap your electronics there, and you have like a nice pegboard arrangement for your big components.
Oh, okay. Yeah.
Just something to keep in mind. You don't want to just like hot glue or glue stuff to that.
I use DIN rails.
DIN rails.
If you're happy with DIN rails, that's an easy one to do.
Yeah.
I get a lot of DIN rail equipment.
Well, the whole thing has to be very flexible, and I don't want to commit too much to a form factor. I just want to play it by ear as I go.
To
Plan
expand
on a
on,
couple more versions.
Yeah.
to expand on the concept about putting a board or something in, if you mount all your stuff to a plate and the plate goes inside and you have like 2 to 4 screws that hold it in, that
Yep.
way you can take the screws out, put the plate on your table and get to it. You can get to put your couple screws to hold it down. Because otherwise you've got this big box, you're trying to reach down inside,
Yep.
screw everything down and wire it up. That doesn't work. You know, the little box you already made, you probably understand that concept. So, but all the industrial people will get these big boxes.
The hard way.
You got these big plates in there, so you just unbolt it and take them out.
Well, our budgets are a little different.
That's looking good, Bob. Really interesting.
Who's next?
Yeah, who's next? Vinny's been doing some work. I did download your last week's changes and was able to test that, but not the new lattice planner. I haven't downloaded that one.
Okay. So yeah, for the whole group, trying to come up with a global planner, well, not come up with, but implement a global planner that behaves according to the constraints of the lawn tractor. You know, Ackerman steering, non-holonomic control. The current generic global planner doesn't produce paths that are necessarily achievable by the vehicle. So the local planner takes care of that, but I think you lose a lot of efficiency there. So I've, you know, the first month or so, maybe it's been 2 months since I first took this on. I tried this plugin called the Hybrid A-Star Planner. Came up with weird results. I'm not very familiar with C++, so I couldn't get to the bottom of it. But recently I found something called the Lattice Planner, and it's something that's built into, you know, there's more ROS support from the community, and it plans based on motion primitives, which are like MATLAB generated kinematic constraints the vehicle can go in. So instead of searching your grid based on diagonals and sideways from your vehicle, it will actually draw short paths, and that's where your motion primitives come in. So once you feed these motion primitives to the Lattice Planner, it will be able to do your traditional, you know, A-star or whatever, incorporate those motion primitives, and then get you a kinematically feasible path. So in the lawn tractor Slack, I posted some GIFs of it working compared to the generic planner. And even though I don't have the correct motion primitives loaded in, it does already seem to be an improvement. So I think my next step is to come up with the motion primitives that actually describe the lawn tractor vehicle.
Okay, here's his demo.
And I don't know why my screen recording software makes the tractor blue.
So it adds in a curved path to get you going instead of like a straight corner.
Right. And the generic planer will just draw a straight line.
Very cool, Vinny. So that I haven't tested that on a real robot, but I am excited to do that. I think that will be really cool to see. And then, yep. And then the local planner, the TEB, is the configuration that actually tries to drive those paths. So there may be some work there, and there may be some like tuning for each specific vehicle, especially on the size and then how it responds.
Right. I think another improvement that we can make is making the is the URDF of the tractor currently set up such that it will not perform motions that are not kinematically feasible?
No, there was a lot of double negatives in there and I wasn't sure.
Sorry. The question is the URDF set up in a way such that it will only produce motions that are kinematically feasible?
From the vehicle itself?
Yes.
No, it doesn't act like a real vehicle. So some of the times, like if the difference between the simulation, some of the vehicle parameters aren't correct. So we need those sizes to be correct in the URDF. But when you move to the real vehicle, let's just say, for example, like yaw, like maybe you needed to back up a little bit to get on the path, like in that demo.
Right.
In simulation, the tractor will slide its front wheels, like, and you can't do that in the real world. You know, it almost kind of acts like a differential vehicle, just a little bit, and that'll move your heading over, and then you can hit the path. But when you're on the real vehicle, it doesn't do that, and so it kind of like oscillates it. You know, like it's trying, and then it says, "Hey, I can't reach my goal in the amount of time." But it's just a tuning. It's a tuning parameter if you can get that.
Is it worth? And do you know if it's possible to set up the URDF such that it will not slide in place?
It should be. I mean, I liked your point about we should make the simulator as accurate as possible. Like if we're getting an error on the vehicle and we're not getting that error on the simulation, then maybe we could take a look and see what the difference is. But there's some value in that, in the sense that well, I guess every person's robot will be a little different, like the sizes and the responses. But I think maybe the next goal is to put that on a real robot and then see what happens, and then kind of go back and edit the URDF. What do you think about that?
Okay, because I'm also thinking if we make the URDF constrained, regardless of, you know, specific size or whatnot, but at least it would have the constraint to where it would not slide in place. That would just help us develop and tune both the local planner and the global planner.
Yep. I have never tuned a simulator. I've only tuned, I've always kind of thought, I've been of the opinion, I don't waste time trying to tune a simulator because it's always different when I get on the vehicle. So it's like, you know, I just get the simulator moving, do whatever, and then I get on the real vehicle and then do those, do the tuning on the real vehicle. But it would be, I've never done it. So it would be interesting to see if we can get the simulator to throw the same errors as we're getting with the real vehicle.
I think it's worth the effort. At least in my lab, that's what we'd do. Like the simulator would be as close to possible as, you know, the real vehicle. I mean, without going computationally crazy, but making constraints on the URDF is not a computational limit. It's, you know, we have to spend some effort and time, but I think it does help close the development loop.
Yeah, like we don't have the inertial parameters set, I think, on the simulator.
Okay.
And so that's the big one. And then I don't even know if Stage takes those into consideration. So we may need to go to Gazebo to get the more of a better model, better physics model.
So Stage is a separate simulator than Gazebo?
Yeah.
I thought Stage was built on, okay. They're different platforms.
Yeah. Stage is just a 2D simulator, pretty simple, very, very simple. And then Gazebo is the 3D simulator.
But I mean, so in here, I'm wondering if you actually need a 3D simulator, because if the lattice, like if you're using the lattice planner or even the TEP planner, I believe it's 2D. So do you need the third dimension of Gazebo in that case?
That's a good point. Not for the planning, but what about trying to get the vehicle to behave like a real vehicle, like the physics part? How fast it ramps up and how it moves.
But that depends on what you're trying to simulate. If you're trying to simulate how the plan is working, or how does it, I mean, I don't see any point in being able to simulate the physics so long as you have the dimensions correct. You should be able to generate the same plan on both vehicles in simulation and in real world. I think dimensions are your key and not the physics of it. Like it shouldn't matter how fast your simulator accelerates, or how close is the simulator in terms of mimicking acceleration to the real vehicle. As you know, I mean, it doesn't matter if it goes as fast to the desired speed and, as a rocket, you shouldn't.
You're going to get there eventually. Like one will be a little bit slower, one will be a little bit faster, but you'll still get there.
But I mean, your path planning and path following should be, more or less the same. I mean, if you're testing path planners.
Do you agree with me in the point that we should make the length and the kinematics in the simulator kind of match real life?
Yeah.
And what you're telling me is we don't really care about the time element.
Yeah, I agree. I don't think you need. Okay. I don't think you need the physics part of it, but I definitely think you need the dimensions of it, because you can't have a really tiny tractor and the real tractor be 10 times as big or more, because your turns and things would be different, right?
Right, because it's impacting the path following capabilities at that point.
Yeah, there may be two different things. One I heard is the path planning, and path planning, you can use Stage. It's great for that. It's really lightweight and you can do testing, but the path following, getting your vehicle to follow that path, I'm not sure what that looks like there.
I agree that simplifying to 2D is worthwhile, and I've always done my path work in 2D. It will be nice. I think you'll want 3D at some point for things, especially if you're mounting a GPS antenna really high. It's nice to have. I would love to have a good simulator for that stuff.
But I mean, when you're mounting a GPS antenna up there, you are publishing transforms to, so essentially at the end of the day, your GPS antenna to ROS is at baselink, right?
Oh, absolutely. For path planning, yep, absolutely. It's all 2D for me. Except on a hill. It is the only time it might get interesting, but no. For the path planning, absolutely. I'm a 2D proponent.
Okay.
So it looks like I have two things to work on out of this: is generating the real motion primitives, and then number two is tuning the URDF such that it's at least realistic.
Yep. Yes. I have no idea how to do either of those. So
I was going to say the next step is teach us all how to do it.
yeah, I was like, that sounds awesome. Let's do it.
Well, I don't know how to do them either. So once I figure it out, I will teach you guys.
Okay. I can get you the real vehicle dimensions, and then if you need anything else, I could collect data of how it moves and turns and all that stuff.
Okay. I might take you up on that.
It'd be kind of fun to figure out a way to record data off of the vehicle as it's moving around and then generate those.
So I've tried to do that with my boat. What we did was we collected a lot of IMU and GPS data, and we tried to fit the hydrodynamic constants of how it's moving through water. I think we came up with like 4 or 5. Try to fit that to the motion of the vehicle. That project was very, very difficult. So yeah, I never ended up finishing, but that was a big research push to do that.
Yeah, it would be super handy because then it would be pretty easy to get your real vehicle into simulation.
Right. And have a like a tool chain that everyone can pursue.
Exactly. Yep.
If instead of just observing, could you have an active probing mechanism that figures out the kinematics of the vehicle? So actually exercise it and get your values from that.
That is a good idea. I guess one can come up with some routines and like isolate like a forward motion and how much. Yeah, that is a good approach, I think. Have you done that before?
I have. I have, especially on my differential steer or differential drive tractor. Yeah, I've got a field that's really torn up from doing it. Just running it through routines where I try different things repeatedly. Not for a URDF model, but just for my internal programming. So yeah, having something where you can run it through lots of different stepwise through lots of different values, I think would be valuable.
Okay.
Is this close to the Lucas Robotics fuse? Have you seen that package?
I am not.
I will post a link here.
So this seems like it's for like sensor fusion, which I guess if you have a fused observation, then you can start fitting physical parameters.
Yeah, yes. This goes to your localization. I mean, but they kind of have like a vehicle, a model in here. And then you take all the sensors and then where would the, I didn't post that in there. I was looking for their diagram. There is a talk at ROScon. But it's kind of like they have a vehicle model and then, but that vehicle model is, that's kind of what we need into the, that's your primitive file, or that's what goes, I don't know.
Right. I mean, I don't know, maybe the motion primitive is not as complex as a full model of the vehicle. I still haven't dug around, but right now the primitive I'm using is called the unicycle model with no turn in place.
Yep, sounds like an Ackerman vehicle.
So, oh, these are good threads. I'm gonna keep on exploring.
Okay, that's awesome.
I think this is a better path forward than that A-star planner that, you know, I was stuck on for 2 months. Didn't have much to show for it.
Well, I think the Lattice planner is a great planner, and they also use that in 3D planning too. So that's kind of a nice advantage. Same path planner. Thanks for the update. Thanks for the work. That's really cool.
Thanks.
We have any other project updates tonight? Got about 6-7 minutes.
I can just I can just give a quick update. I didn't do much this week, but what I did do was can you see my Excel spreadsheet at that point?
Yes.
Okay, so this I just took my robot out in the yard and set a told it to drive for 5 seconds before it times out and set a speed of 0.5 meters per second. And here's a gain factor of 300. That's just a relative, just a random number. And I said go, and it drove for I think 2.5 meters and comes to a stop. And what I wanted to find out is, I run it faster, or I want to run it with a higher gain. So here's somewhat higher gain, and the peaks are a little bit smaller. I get just a little bit of starting to get a little bit of oscillation there, and run up another one. And these are getting a little bit smaller, and I got more oscillation trying to happen. But if you turn it up too high, it does this to you. So that could be a real problem there. So now if I go back and rerun these things and adjust the derivative gain, theoretically I can get rid of this where it starts to oscillate. And that's basically where I'm at right now. I can just drive the thing and see it do this. And it's fairly easy to do. I just get down on my knees with my robot in front of me, type on, I got a laptop on top of it, I type in the thing and say go. It drives this 2.5 meters, and I take the remote control, back it up again, I type in the next numbers and tell it to go again. So it's the biggest thing, just dragging the thing out in the front yard to get it set up is my biggest drawback there, and my lack of ambition. But it looks like, so anyway, this graph, what this is, the blue is the computed velocity. This is how fast I want it to go. And then the orange is this is the actual speed coming back from the motor. And technically, if I go look at, let's go back to a reasonable one here. And if you go back, look at the top here, this is actual, this is the position as it's driving. So the position's following, this is the computed position and the actual position. And there's nothing really wild there. It's just when you put it on the graph, it looks bad. But, and I guess this plot right here, this green line is my max power I can put to the motor. And I'm only driving about 50% of the, using about 50% of the motor to maintain this speed. So it's coming together, and I just got to play with it some more. So I guess that's the extent of my update for this time.
What how close are you looking to hold your miles per hour or your meters per second?
Well, ideally it would follow exactly, but I don't know at this point. I go look at that, and here, let me pull it up again here. And
I mean, can you see it lunging at 300 there or 500?
At the 300, I could. It looked like it would speeding up and slowing down. But the thing is, the numbers here, this is off by what, count of 50 from the max to the min. And I get 2,400 counts per revolution of the motor. So it's some fraction of a motor turn is what this actually is coming out here. I think it's what that's doing. But yeah, you can see it change a little bit. But it seems to be completely controllable. The way ROS works, it says drive ahead at their speed. And it doesn't have to be exact, because you're sending back the odometry information saying, here's where I actually am, here's how fast I'm actually going. So ROS does an overall control loop on that. But it's close enough at the moment. I could just put in a number. I'll probably put in what's this one, 600 here. I'll probably put this number in, and for the moment, just play with that until I get around to going out and tuning the rest of it to get it to do that. And this is actually, I'm using a position control. So what I'm doing is specifying, if you look at this graph, in order to get this computed position of where it's supposed to be, I just keep moving the target position along, and it's got a position PID that's trying to follow that point. So it's trying to say, I am here, but I need to be there. So that's what's controlling the power down here. So if you look at this actual line right here, this orange line, I believe, is the position error. So this right there is how far off it is, and the PID is just that multiplied by a gain factor. And then this is the responding velocity that it has. So I've got all the pieces there, and I just got to play with it some more and see if I can get it to calm down and do something more reasonable. So
Awesome.
Cool.
and one other point I was going to mention, that I was watching the old videos and I was looking at my backgrounds. I thought, since I was just randomly grabbing these from anywhere on the internet, I don't know if they're copyright images or not. So I specifically deleted all my images and went to pixabay.com, and they're all their images are all free. So this is a brand new image I got here from a background tonight. And if somebody complains, I don't know, they might go to YouTube and say, take this video down. It's got my copyrighted information. I think the only alternative is to delete the video. I suppose you could delete the video and keep the audio. That would be without losing the whole thing. But anyway, that occurred to me. So anybody who does backgrounds or just has stuff in the back that people can see, that is always a possibility that somebody's going to complain.
It hasn't happened for backgrounds yet, but there was one video. The Liner Robot gave a demo, and there was a song in the video when he was playing the song, and then somehow that came up and said, "Hey, this is a copyrighted song."
Did you have to do anything about it? Did you have to delete it or?
Yeah, there was like a little clip of I don't know how long it was. It wasn't very long, but a little clip had to be removed.
So you're able to just go and cut out pieces at that point?
Yep.
So,
So
images,
I can't use my bunker?
He's in his bunker. It's a secret location.
As long as it's your bunker, you've got the copyright on that. It says something down in the corner that I can't see what it says though.
Google gave it to me.
Minecraft.
Well, just depends if those people are going to complain. So
There's no copyright there, right?
I don't know.
But we don't know who actually made that though. They might have broken the copyright by putting that name on there. So
Yes.
but I don't know.
I think
Well,
we'll be okay.
just something to think about.
Yep. Great. We're at the top of the hour now. Great seeing everybody. Thanks for the discussion. Thanks for the project updates. Joe, it's great seeing you. Thanks for letting us in on your new device that's coming online here.
Oh, always a pleasure. And here, just one last one for you. It's not ag, but my buddy David, he made a Raspberry Pi coronavirus detector. And I just gave you the GitHub, the open source for how to build it.
Timely.
Listen to my show while you're finishing.
Thank you much, folks.
You bet. All right. You guys have a great week.
Good night.
Good night.
See you guys.
Yeah.